Hello and welcome. In our lesson today, we are going to tackle past KCSE questions on extraction of iron. Below is a question from KCSE 2006, paper 2. So the question goes as such: the extraction of iron from its ores takes place in the blast furnace. Below is a simplified diagram of a blast furnace. Study it and answer the questions that follow. So as you can see, from the top of the furnace, we have a mixture that is being fed into it. Now this mixture contains three components. There's hematite, which is iron 3 oxide, there's coke, which is carbon, and lastly limestone, which is calcium carbonate. Now limestone, on encountering the high temperatures within the furnace, decomposes to form calcium oxide and carbon 4 oxide. Now, calcium oxide plays a role in removal of impurities present within the ore. Now, maybe just a recap. Iron ores tend to contain quite a few impurities, but two of the more common ones are silica and aluminium 3 oxide. So what happens is that calcium oxide combines with both the aluminium 3 oxide and silica. This leads to the formation of calcium aluminate and calcium silicate respectively. So these two components form the slag. Now if you look at the diagram of the furnace, you'll note that on the lower parts of it, there's a tube leading out of the furnace, and this is used for the removal of the slag. So slag is simply a waste product. Now moving on to the coke. Now coke is carbon. So what happens is that carbon reacts with oxygen present within the furnace to form carbon 4 oxide. Now this reaction is highly exothermic. That means that it evolves large quantities of heat energy. Carbon 4 oxide on rising encounters carbon, unreacted carbon. So the carbon then reduces the carbon 4 oxide, leading to the formation of carbon 2 oxide. Carbon 2 oxide then acts as a reducing agent. This simply means that it reduces the iron 3 oxide, which is hematite, to iron metal. Okay, I believe we are now ready to tackle the questions. So A Roman 1 says, name one of the substances in the slag. Now this can either be calcium silicate or calcium aluminate. Roman 2, name another iron ore material used in the blast furnace. Now iron has three common ores. There's hematite, which is considered to be the chief ore, but it also has two other ores, and these are magnetite and siderite. So either of these is correct. Roman 3, one gas which is recycled. Now this of course is carbon 4 oxide. Okay, let us move on to part B. Describe the processes which lead to the formation of iron in the blast furnace. So carbon reacts with the hot air to form carbon 4 oxide. Carbon 4 oxide is then reduced by carbon to form carbon 2 oxide. The carbon 2 oxide then reacts with the iron 3 oxide to form iron metal. Okay, part C. State the purpose of limestone in the blast furnace. So of course, it's to produce calcium oxide, which reacts with silica or aluminium 3 oxide to form slag. This is important because it leads to the removal of some impurities. Okay, I believe we are ready to tackle another question. So this question is from 2020, paper 2. Part A goes as such. One of the ores of iron is hematite, which is iron 3 oxide. Give the name and formula of two other ores of iron. Iron has three common ores. There's hematite, of course, there's also magnetite, and lastly, siderite. So siderite is iron 2 carbonate. Part B. In a certain factory, iron is extracted from the hematite ore using the blast furnace as shown in figure 1. The other raw materials are coke, limestone, and air. The melting and boiling points of iron are 1535 degrees Celsius and 3000 degrees Celsius respectively. So that means that the melting point of iron is 1535, while the boiling point is 3000 degrees Celsius. Roman number 1. State how the temperature in region 1 compares with that in region 2. Give a reason. Now, before I answer this question, let us just discuss the different temperatures that are found within the furnace. So I'll be focusing on region 3, 2, and 1. Now, at region 3, this is where you have the highest temperatures within the furnace. Now, the main reason why the temperatures are extremely high is because of the exothermic reaction that occurs in this region. Now, which exothermic reaction am I referring to? The formation of carbon 4 oxide. So in this level, carbon combines with oxygen to form carbon 4 oxide. This is an exothermic reaction. That simply means that heat energy is evolved. So this results in the high temperatures that are found in this region. So the temperatures in this region can go as high as 1600 degrees Celsius. At region 2, temperatures become lower. So as you can see, the temperatures are as low as 700 degrees Celsius. Now, one of the contributing reasons why the temperatures are low is because of the endothermic reaction that takes place in this region. Which endothermic reaction is this? The formation of carbon 2 oxide. So in this region, you have carbon 4 oxide being reduced by carbon to form carbon 2 oxide. This reaction is endothermic. That simply means that it leads to the absorption of heat energy. This causes a decrease in the temperature. Lastly, region 1. Now, at region 1 is where the temperatures are the lowest of all. So you have temperatures that can go as low as 300 degrees Celsius. Now, one reason is because some of the heat energy is being lost to the surrounding through the openings on the upper layer. This, of course, is in form of processes like radiation. So back to our question. So the temperatures at region 1 are lower than those at region 2. Now, this is because some of the heat energy is lost through radiation, and also because the raw materials that are being fed at the top of the furnace are not preheated. So this causes a decrease in the temperature. Okay, moving on to Roman 2. The main reducing agent in the furnace is carbon 2 oxide formed by the reaction. So we're having a reaction whereby carbon 4 oxide is reacting with carbon to form carbon 2 oxide. Write 2 equations to show how carbon 4 oxide is formed in the furnace. Now, there are actually 3 reactions that are responsible for formation of carbon 4 oxide. Reaction number 1 is that of decomposition of calcium carbonate. So calcium carbonate on heating decomposes to form calcium oxide plus carbon 4 oxide. Another is the reaction of coke, which is carbon with oxygen that leads to the formation of carbon 4 oxide. And lastly, when carbon 2 oxide reduces the ion ore, this also leads to the formation of carbon 4 oxide and the ion metal. So these are the reactions involved in the formation of carbon 4 oxide. Now, any of these 2 is correct. Roman 3, suggest a value for the temperature in region 3, give a reason. So the temperatures in region 3 are around 1600 degrees Celsius. Now the temperatures are of course high because of the blasts of hot air and the exothermic reaction that takes place in this region. Now these high temperatures are very important because they ensure that the iron remains in molten state. Roman 4, name the main component in the slag. So slag actually contains 2 components. There's calcium silicate and calcium aluminate. But the question is asking us for the main component, and that is calcium silicate. Next question, state one role that slag plays in the blast furnace. So what happens is that the slag as well as the molten iron usually move to the lower parts of the furnace. But the slag has a lower density, so that means that it floats on top of the molten iron. Now this plays an important role because it prevents the molten iron from being oxidized by oxygen present within the furnace. So simply means that It prevents the ion from reacting with any oxygen present to form an oxide. Last question. The iron produced in the blast furnace is brittle due to the presence of impurities. Number 1, name the main impurity in this iron. So there are several impurities that are present in this iron, which is called pig iron. So there's carbon, silicon, manganese, sulfur, and others. But the main impurity is actually carbon. State one use of this iron. So this iron has quite a few uses. Some of the more common ones are that it's used in the manufacture of steel, in the manufacture of electric poles and fire grills. So this brings us to the end of our revision exercise. I hope you've been keeping pace with me and have benefited a lot from it. Please follow for more revision exercises. See you there.